Hello friends, I welcome you in lecture number 3 on hypothesis testing. In this lecture also we will discuss one question which was asked in GTU Winter 2020 exam, and this question is related to the large samples hypothesis test for a population mean. We have discussed the hypothesis testing procedure for this type of hypothesis testing in earlier two lectures. So first we read this question. A stenographer claims that she can type at the rate of 120 words per minute. She demonstrated on the basis of 100 trials an average speed of 116 words with a standard deviation of 15 words. Does this enable us to reject the null hypothesis mu equal to 120 against the alternative hypothesis mu is less than 120 at the 0.05 level of significance? So in this question you are already given what is null hypothesis and what is alternative hypothesis, and level of significance is alpha equal to 0.05 and population mean is 120 words and sample is of size n equal to 100 with sample mean x bar equal to 116 and sample standard deviation s equal to 15. Because sample size is large, here we can see n is 100 which is greater than 30. Therefore we can apply the large sample hypothesis test for this hypothesis testing procedure. Here sample standard deviation is given and population standard deviation is unknown. So we can replace sigma by sample standard deviation in the formula for Z statistic. So first we write down what is given, and here it is already given that null hypothesis is mu equal to 120. We denote null hypothesis by h suffix 0 and it is mu equal to 120. And alternative hypothesis is mu is less than 120. So here we can see this is one-tailed test because we are considering alternative hypothesis as less than type statement and the level of significance is 0.05. So we have to test this hypothesis, null hypothesis mu equal to 120 at 0.05 level of significance. Also we write down the given things. Another things given are sample size is n equal to 100, mean of sample is 116 and sample standard deviation is given as 15. Now here sample size is large and therefore we can say that the appropriate statistic is Z statistic, and we know that this Z statistic given by Z equal to x bar minus mu over sample standard deviation over square root of n is a standard normal random variable. So now we calculate this value of Z corresponding to given sample data. X bar is 116, population mean is 120, sample standard deviation is 15 divided by square root of 100 which is 10. So this is going to be 116 minus 120, that is minus 4, 15 divided by square root of 100 which is 1.5. Therefore value of Z statistic is minus 4 upon 1.5 which turns out to be minus 2.67. So this is the value of corresponding Z statistic which we have obtained using the given sample data. Now once we obtain the value of Z statistic, we have to decide the rejection region. Now here we have alternative hypothesis which contains this statement less than type statement. So we have a one-tailed hypothesis test here, and the level of significance is 0.05. And if we recall that this z statistic is a standard normal random variable, so its graph is a bell-shaped curve. We can roughly sketch this graph of standard normal random variable, which is always a bell-shaped curve, and at the center we have 0 somewhere here, and suppose this is alpha. So suppose the area covered by this tail is alpha, so that this point is z suffix alpha, and because we are having less than type alternative hypothesis, we will consider this point, which is corresponding to minus z alpha, and this area is also alpha. So we know that area to the right side of z alpha or area to the left side of minus z alpha are equal due to the symmetry of this bell-shaped curve. Now our test is one tail test, so we are not interested in this area. Our rejection region will be in one tail only, because we have less than type alternative hypothesis. So if we calculate this critical value of minus z alpha, and if our z statistic is smaller than this value which we will calculate, then we can say that null hypothesis is rejected. And if value of z statistic is not in this region, then we cannot reject null hypothesis. So first we have to calculate value of z alpha or minus z alpha corresponding to this area. So for that we use this fact. We know that probability that z is less than minus z alpha is this area, which is alpha. Now we are interested in the value of this minus z alpha. So from this we can rewrite this as, this is exactly equal to probability that z is greater than z alpha. Okay, as I discussed, area in both the tails is same. So if I consider this area, which is to the right side of z alpha, then these two areas are equal, both are equal to alpha. So we are using this symmetry to decide the value of z alpha. Now this is again can be rewritten as 1 minus probability that z is less than or equal to z alpha equal to alpha, and here value of alpha, that is level of significance, is 0.05. so here we write z less than or equal to z suffix 0.05 equal to 0.05. Therefore probability that z suffix z is less than or equal to z suffix 0.05 will be equal to 1 minus 0.05, and therefore this cumulative probability z is less than or equal to z suffix 0.05 is equal to 0.950. So from the table of cumulative standard probability, we will find out value of z suffix 0.05 such that this probability is 0.95 or area under the normal curve is 0.950. So for that we find out this area 0.950 in the cumulative standard probability table. So in this table we search for 0.95, and if we don't obtain 0.95, we will search for those area which is approximately equal to 0.95. So here we can see, here we have 0.9484, 0.9495, 0.9505. So we can see these two values are closest to 0.95 as compared to remaining values. This is also near to 0.95, but this is more near to 0.95 as compared to this one. So we find out that value of area which is very near to 0.95, Now difference of 0.95 with these two values is same, therefore we will consider both the values and we will take the average of corresponding z values. So in this row the value of z is 1.6 and we have to search for these values. For 0.9495 we have 0.04 here, and for 0.9505 we have 0.05 here. So value of z corresponding to 0.9495, the value of z corresponding to this area is 1.64 and the value of z corresponding to 0.9505 is 1.65. So our z will be average of these two values of z, 1.64 and 1.65. So therefore z suffix 0.05 will be equal to average of 1.64 and 1.65. So therefore z suffix 0.05 is equal to 1.645, or z alpha is 1.645, therefore minus z alpha is minus 1.645. So from this we can see that the area to the left of this value of z suffix 0.005, alpha is 0.05. So if we consider this area which is to the left of minus z alpha, then this is the rejection region. If value of z statistic falls in this region, then we can reject our null hypothesis. Now if we observe, the value of z statistic which we calculate is minus 2.67 and it is less than this value of z, minus 1.645. The calculated value of z statistic is minus 2.67, so that will be somewhere on this side. For example, suppose this value is minus 2.67, so it is in the rejection region. So because value of z statistic is less than this value, or critical value of z, we will call this value as critical value of z. So value of z statistic minus 2.67 is less than this critical value of z, therefore we reject the null hypothesis. So here we write that value of z is minus 2.67, which is less than minus 1.645, which is nothing but minus z suffix alpha. That is, z is strictly less than minus z alpha, therefore we reject the null hypothesis, because this value falls in the rejection region. We reject the null hypothesis, which we denote by H naught. And we can see here our question is, does this enable us to reject the null hypothesis mu equal to 120 against the alternative hypothesis at the 0.05 level of significance? So answer is yes, this enables us to reject the null hypothesis mu equal to 120 against the alternative hypothesis mu less than 120. So here we have written that we reject the null hypothesis H naught against alternative hypothesis H suffix A at 0.05 level of significance. At 0.05 level of significance. So in this way we can answer this type of hypothesis related questions. Method is simple. You just have to first decide what are the null and alternative hypothesis. Here they are already given. Then you have to decide which test statistic is appropriate for given problem. Here sample size is large, therefore we are using Z statistic. So using that formula of that corresponding Z or whatever statistic is appropriate, we calculate the value of that statistic, and after that using the level of significance we find out the critical region or rejection region. And if our calculated value of Z statistic lies in the rejection region, we reject the null hypothesis. Otherwise we are not able to reject the null hypothesis. So in this way we can answer this type of questions. So this is all about this lecture. I hope you like it. Thank you very much.